Welcome back. As I mentioned in my previous video, I will come back and solve a couple of structures for the compounds I asked you to work out. Now, what I'm going to do here is not give you an exhaustive list of all isomers possible. However, I will try my best to draw a few different ways and find out what you may think and how that might be maybe wrong. And I might not do the C7H16, right? So let's actually look at it, look something else quickly before we move on. And that would be, say I give you this, just this structure, and I ask you maybe down the line when we've actually learned alkenes and alkynes as well, is the formulae corresponding to a saturated hydrocarbon or unsaturated hydrocarbon? Well, we know only alkanes can be saturated hydrocarbons, right? And the general formulae for alkanes is CnH2n plus 2. The question is, I can ask you, is the formulae corresponding to an alkane, alkene, or alkyne, or is the formulae corresponding to a saturated or unsaturated hydrocarbons? The answer is essentially the same. All you have to do is put the number of carbons in the formulae, okay? If it gives you this, then that matches what you have at hand, and this can only correspond to one thing, and that's alkanes. An alkane only corresponds to one thing, which is saturated. Does that make sense? You see, this connecting aspect, what might cause some people to not like chemistry or might find chemistry hard. All right, it's all these interrelated components. All right, with that said, as I always said, your first job is to write the longest chain or the parent chain, which you have 6 carbons. So write 6 carbons all in a row. Write 1 bond outside, 1 bond on this side as well. Now you can start simply putting bonds above and below. Why? Because every carbon in every direction can only have 4 bonds max, and it's a must. It doesn't have an option to have 3 or 4. You can have single, double, or triple bond, but you would still see the carbon has 4 bonds. Now, if you see the carbon is surrounded by 4 bonds in every angle I look at it, all right? Now let's go start putting hydrogens on the ends. So hydrogen, hydrogen, hydrogen. Now, as I said, I am not going to draw every possible isomer for this compound, okay? Because that's the whole purpose of you learning the concept, is you should be able to try this at least, all right? So CH3, the condensed structure would be, I just write how many carbon and how many hydrogens are attached to each carbon. So, you know, this is what it is. This is the first structure. And this is actually the parent, the longest chain, okay? Longest, okay? It's the maximum longest chain possible. Now what do? We write, instead of writing 6 in a row, let's write 5, okay? Now, you can't put it on the end. If you put it on the end, you've just made what you just drew. So you draw 5 instead of 6 and start putting the odd one here. Now, as I said, if your compound only contains carbon and hydrogen, then if you had started on this side, would make no difference. That is what I'm saying here is, you could have started here where I just put the dot. You could have started here. You would have made no difference, okay? Does that make sense? Okay. So now this carbon still only has 3 bonds, so let's put 1. This carbon has 1 above, so let's put 1 to the left, to the right, and down. 1 above. There you go. So get a visual opinion first. Make sure that every carbon has, you know, every carbon has 4 bonds, and the hydrogen count when you finish should match the hydrogen count total, which should be 14. If you have more or less, then you have made a mistake somewhere, You just have to go fix it. Please do not connect these two hydrogens here. All right, now what we have is, let's get a different. So basically, this is what is my stuck-in structures. As I said, I am not going to draw every single structure in the world for this, because then the video is going to be too long. And again, it leaves you no room to practice. Okay. Now we did 5, right? See if there's a possibility you can still do a structure with the 5 itself. If not, move on to 4. But I still think if I put it in the middle, it doesn't look like what I have created so far. These two structures look uniquely different. Now, what I also want to point out is, I said this is the longest chain, right? This, in this case, is the longest chain. You got 5. Again, we still have the longest chain as 5, okay? But the longest, and then the longer, and then longer, as you keep going, you see a chain become smaller and smaller. But the longest chain is the parent. All right, so let's go start putting our bonds. I mean, for me, this comes naturally because I've done this too many times. For some of you, this might be an acquired taste, and it takes time for you to get used to it. And you see, I'm also talking and drawing at the same time. Again, that comes from just practice. You may have to just watch the video, pause in complete silence, practice, and come back and do it. There we go. So that would be CH3, CH2, CH. Just basically write down what you see in front of you, except we're condensing it this time. So this is the third structure. This structure has no resemblance to this whatsoever, and this has no resemblance to this whatsoever, because your chain, okay? Your chain is different each time, and where the position of that CH3 is different. Let me do one more, because that way you can get an idea on what I'm talking about. So we're still on C6H14. Okay, I did 5 carbon chain, and I believe that's the most you can go with the 5. And now I'm going to 4. Now, if I put it anywhere here, the remaining 2, if I put it here or here, then it's going to look like the longest chain or anything I've created before. So I'm going to put 1 here, and I'm going to put 1 here. See, still my chain is still this. Okay, that's my longest chain. This cannot be my longest chain because that's only 3. Okay, so that's my longest chain. So now let's go start putting bonds around. Okay, this carbon already has 4 bonds, so you cannot take any more hydrogens. This, however, on the other hand, can have 3. This can have 2 more. This can have 3 more. So let's go put the hydrogens on them. So hydrogen, 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 hydrogen. See, that's why I'm not teaching you naming, because naming is more complex. And if you don't really have an understanding of how the structures work, like drawing them, naming might actually become difficult for you, because it's not always going to be, I'm not going to always give you a straight chain and have you name it. All right, it's going to be different. All right, and there are a lot of rules, so it's easier to first work with what we have. So let's draw everything back again. This carbon is attached to CH3 on one end, CH3 on the other end, and a CH3 on the other end. Now, this does not share any resemblance whatsoever to anything you have created. Okay, that's 4. We can keep going. I want you to try a couple more structures, say 5 and 6, maybe. I think there's one more, maybe 7, maybe. Is there an 8? Try. Eventually, you have to, once you create, you have to assess whether what you have in front of you, is it the same structure? All right, do that for C7H16 as well. And if you have questions, please feel free to ask me. All right, maybe in the end, I will make one video where I still don't think it's possible for any one person to draw all structures, because that's very, very time consuming, which is why when I give you an answer choice, I could give you 4 choices, 3 could be clearly not a correct structure for that formulae. So there can be only one that's possible, and you have to figure this out. There's multiple ways I can test this. All right, so keep practicing this, and then I'll be able to answer any questions you might have on this topic. This is how you draw isomers. That is, all of these have, say, 6 carbons and 14 hydrogens, but how they are positioned is different. All right, so stay tuned.